This is Course 3, Chapter 4, Lesson 5, Compare Properties of Functions. When you compare two functions, we're comparing tables, graphs, equations, or words. Even if they're in different forms, we can compare them. So go ahead and pause your video and try these problems from yesterday. How'd you do? Our essential questions is how can we model relationship between quantities? We are going to be comparing properties of functions. What you need to be learning today is to compare two functions represented in different forms. So here we have a zebra and a lion. As you can see from our problem, the lion can run at 53 feet per second, and we have to figure out how fast the zebra runs from the graph. Okay? So we have to compare their speeds. We can see from the problem a lion runs 53 feet per second. For the speed of the zebra, we've got to find the rate of change between 2 points. So you'd use y sub 1 minus y sub 2 over x sub 1 minus x sub 2. And that's what they did here. They picked 2 points and solved the problem. But if you have a 1, and if that also tells you the problem. They got 59 feet per second. So when you compare them, the zebra can travel 59 feet per second, which is greater than 53 feet per second of the lion.
McGraw-Hill Personal Tutors. A mountain goat's main predator is a cougar. Cougars can run at a speed of 52 feet per second over short distances. The graph at the right shows the speed of a mountain goat. Compare their speeds. So we're told that a cougar can run at 52 feet per second and this is over a short distance. Now let's compare that to the information we're given here about the mountain goat. So we're given a graph about the mountain goat, and we've got some points here. Now, the 52 feet per second corresponds to the rate at which this cougar can run. So we want to find the rate or the slope of this line. So I've circled 2 points, 2, 44, and 1, 22, and I want to find the slope of this line. So we're going to say that the slope is equal to 44 minus 22 over 2 minus 1. And so here we're going to get 22 over 1. So in other words, this means that the mountain goat can run 22 feet per 1 second. Now if we compare this to the cougar, 52 feet per second is greater than 22 feet per second. So what this means is that the cougar can run faster than the mountain goat over short distances. Thank you for using McGraw-Hill Personal Tutors.
equals 65h, where m is the miles traveled in h hours, represents the speed of many automobiles on American highways today. The speed of stagecoach travel of the past is shown in the table. Assume the relationship between the two quantities is linear. A. Compare the functions y-intercepts and rates of change. B. If you ride each vehicle for 20 hours, how far will you travel on each? Let's begin by comparing the y-intercepts. M equals 65h. If we substitute 0 for h, the result is 0 for m, which means the y-intercept is at the origin, 0, 0. If we look at the table for the stagecoach rate, you'll also notice that 0, 0 would be an ordered pair. At 0 hours, no miles are covered. So the y-intercept for each is 0, 0, or the origin. Now let's take a look at the rate of change. If we're looking for the rate of change, we're looking for the slope. In m equals 65h, the slope is given by the 65. In other words, the speed of the average automobile today would be 65 miles per hour. Now let's use the table to find the speed of the stagecoach. Notice that we have 5 to 10 changes by 5, and 10 to 15 also changes by 5. If we look at the number of miles, 25 to 50 increases by 25, and 50 to 75 also increases by 25, which means the speed or the rate of change of the stagecoach can be found by 25 miles divided by 5 hours, which means the speed of the stagecoach is 5 miles per hour. So a quick recap here. The y-intercepts 0, 0 was the same for both the American automobile as well as the stagecoach. However, the speed of the automobile was 65 miles per hour, and the speed of the stagecoach was 5 miles per hour. Since 65 is greater than 5, the function representing the automobile has a greater rate of change than the function representing the stagecoach. Part B. If we ride each vehicle for 20 hours, how far will we travel on each? M is equal to 65 times h, and we're told we're going to travel for 20 hours. So m, the number of miles, is equal to 65 times 20. And 65 times 20 is 1,300. For the stagecoach, we'll extend the table given. We have hours and miles, following the pattern 5, 10, 15. If we add another 5 hours, we'll have 20. And for our miles, we were adding 25 to each value. So 25, 50, 75, and 100. So what does that tell us? You would travel 1,300 miles by car, but 100 miles by stagecoach.
Okay, so the function m equals 140h, where m is the miles traveled and h hours represents the speed of the first Japanese high-speed train. The high-speed train operating today in China is shown in the table. Assume the relationships are linear. So we know in Japan it's 140 miles an hour, and in China it's 217. So let's compare them. So both of their Y-intercepts are 0. So at no distance, at 0 hours, they don't travel any distance. The rates of change. The Japanese train is 140 miles per hour. We need to use the table to find the speed of the Chinese train. We can see for each hour it goes 217 miles. So it's 217 miles per hour. So the Chinese high-speed train is faster than the Japanese high-speed train. So now after 5 hours, how far will each one travel? So we need to put a 5 times 140 and then a 5 The Japanese train will travel 700 miles in 5 hours. The Chinese train will travel 1,085 miles in 5 hours. So let's look at this one. We have a bowling alley. Okay. So let's compare our Y-intercepts. Package A is C equals 7P plus 5, where C is the total cost and P. Package B is represented by the table. So here we can see these are going up by 1. Nine to 18 is 9. 18 to 27 is 9. 27 to 36 is 9. How much more will package B cost if there are 12 people? So package A has a Y-intercept of 5 and package B has a Y-intercept of 0. Package A costs $7 per person. Package B costs $9 per person. Package B is greater. How much more would package B cost for 12 people? $19 more.
Welcome to McGraw Personal Tutors. Bryce and James are each renting a truck for a day. Bryce's bill is represented by the function y equals 0.75x plus 20, where x represents the miles driven and y represents the cost. James's cost for the day is shown on the graph. Part A, compare the y-intercepts and the rates of change. And Part B, what will be the cost for the day for each Bryce and James for 30 miles. Let's go back to Part A and organize some information. We know for Bryce, his information, his bill is represented by the function y equals 0.75 0.75x plus 20. We recognize that this function is in the slope-intercept form, y equals mx plus b. James's information is represented by the graph. What's the first thing we need to do? We need to compare the y-intercepts. Well, the y-intercept, y equals mx plus b, for Bryce is 20. Or $20. That was how much it cost Bryce to initially rent his truck. For James, we get the y-intercept from the graph. The y-intercept is where the line crosses the y-axis, which would be right here at 25. So the y-intercept for James's function is 25, which means that the initial cost for James's truck was $25. Those are the initial costs for both of the boys. The next thing we're asked to do in Part A is to compare the rates of change. Rates of change. The rate of change is the slope. For Bryce, we go back to the equation y equals mx plus b. The coefficient of the x is the slope. So for Bryce, that would be 0.75. Or it costs him 75 cents per mile to rent his truck. Rates of change for James. Well, we're talking about slope. Slope is equal to the change in y values, y2 minus y1, over the change in x values, x2 minus x1. So if we pick 2 points, let's pick this point and this point. Y2 minus y1 would be 45 minus 35. Over the change in x, 40 minus 20. Or 10/20, which is equivalent to 1/2, or 0.50. In other words, in James's rental agreement, his truck is going to cost him 50 cents per mile. So just to reiterate, to repeat, the initial cost for Bryce's truck is $20. The initial cost for James's truck is $25. Bryce is going to pay 75 cents per mile. James is going to pay 50 cents per mile. Part B, what will be the cost for the day for each Bryce and James for 30 miles? Let's use the function to determine the cost for Bryce. It's y equals 0.75x plus 20. X represents the number of miles he'll be driving. So we're going to make that substitution for X. And after a little bit of calculator work, we come up with 42.50 or $42.50. So under Bryce's agreement, for one day, when he drives the truck 30 miles, he'd have to pay $42.50. Okay, what about James? Well, James's information is given to us on the graph. And so the X represents the mileage. Here's 30 miles. So we're going to go up 30 miles till we get to the line, and then follow that over to the y-axis, which gives us the cost. So again, we went up from the 30 miles and over to the y-axis to the cost. And we read off the graph $40. So it will cost James, for the same distance of 30 miles, $40. Thank you for using McGraw-Hill Personal Tutors.
Okay, so compare the y-intercepts and the rate of change. Our y-intercept is up here on this one. So you know y equals mx plus b. Our b is 60. Okay. Our y-intercept here is 49. So you can see from the graph that Ben's bill has a y-intercept of 60 and Angela's 49, so Ben has a greater initial cost. Okay, for Angela's bill, the rate of change is 15 cents per minute. Let's find the rate of change for Ben's. We have to subtract it out and then divide. We get 10 cents. So the rate of change for Benjamin's bill is 10 cents per minute. Angela's paying more per minute. So if you ride each train for 5 hours, what? That is incorrect. So we're not going to do that one because that sentence is wrong. Here, Angela's monthly cost is written here, so they must have said for 200 minutes. Angela will pay $79 for 200 minutes. Ben will pay $80 for 200 minutes. Go ahead and pause the video and try this one. Our y-intercept for this equation is 5. Here it's 4. And this is one movie is $6. So our thing here would be C equals 6 times M plus 4. Okay, compare their y-intercepts and rate of change. So the first company has the greater initial cost, but the less for the rate of change. If we buy the 15 movies, you will see the second company would cost you $34. The first company would be $27.50.
Brittany is in charge of ordering t-shirts for the math club. The cost from 2 different companies is shown in the table and the graph. Which company should she use if she is going to order 60 t-shirts? So let's take a look at Totally Tees. It says that Brittany is going to order 60 t-shirts for the math club. So let's go ahead and find 60. So 60 is going to be between 56 and 64, directly in the middle. So that's the number of shirts. Now let's see, what does that correspond to in terms of a price? So it looks to be directly in the middle of 300 and 350. So we're going to say that this is going to equal $325. Now, even if that is not an exact amount, we still can compare that to Mr. T's t-shirt company and see how it compares and if it's cheaper or more expensive. Now, let's take a look at Mr. T's, and we have this in a table. Now, notice that the shirts increases by 10. So we add 10 to 20 to 30. So let's continue that pattern over here on the left-hand column. So we've got 40, 50, and then 60 is what we're after. So I'm going to highlight that with blue. Now, you notice that we have an increase of $80. So we go from 80 to 160, and then we go up to 240. So if we increase that by $80, we'll have 320. Increase that by another $80, and we have 400. And then finally we have 480. Now, remember, we're after how much it costs for 60 t-shirts for Brittany to order for the math club. So we have, in Mr. T's case, a cost of $480. Now, if the math club is interested in saving money, it seems wise that Brittany would choose from Totally Tees because there is a large difference in the cost of 60 t-shirts. We have $325 for Totally Tees, and we have $480 for Mr. T's. Thank you for using McGraw-Hill Personal Tutors.
Okay, so Lorena's mother rents a truck. We've got a table and a graph. Okay, we're going to compare them. And we need to find which company should she use for 40 miles. So the cost of renting the truck would be $75 plus $25 or $100 for 40 miles. Find the cost from renting Crosstown movers. Well, if we look, we have to find our rate of change, which is 0.5. So our equation would be 0.5 plus 30. 30 is our Y-intercept. So if we multiply that out, it would cost $50. Crosstown movers would cost less for $40. Go ahead and pause the video and try this one on your own. How'd you do? Go ahead and make sure you do your online assignment or your worksheet and send me a copy.